about tangents. No. Monday we talked about tangents, and that was a line, random line that touched a circle at one point. Right? That red line was a tangent.
Yes.
You guys did okay with that. Then yesterday we talked about chords, just chords. That was one line inside the circle. Today, we talk about two chords in a circle. Y'all grab the notes, right? All right, you're welcome. So, two chords in a circle make an angle, but it's a very specific angle. It's called
inscribed.
It's an inscribed angle because it is inscribed inside the circle, an inscribed angle. So the mathematical properties today, there is only one of them. Let's call this angle I don't know, 45 degrees. If that angle is 45 degrees, you know or should be able to figure out how big the intercepted arc is. That would be this arc right here. You multiply it by 2. So 45 times 2 is 90. That means that blue arc is 90 degrees. There it is. There's the whole lesson.
That's all.
That's it.
I'm scared.
Alright, so now how you guys get confused is stuff like this. I can tell you that this arc measure right here is 100 degrees. And I can ask you for the measure of the central angle. Well, so where is the central angles? That angle in the center, so that angle goes like this, from the center out. Because it's a central angle, it starts in the center. So if this arc measure is 100 degrees, how big is the central?
Degrees.
It's 100 degrees. You'll remember that, right? I gave you guys a circle on your quiz, and I said how big is the measure of each arc, and it was just how many degrees was described by the angle in the middle. This one's 100. But if I asked you how big the inscribed angle is, divided by 2 is 50. Okay? Now everything else is just, can you see it or can you not see it? So let me start over. And draw some lines here. This is us taking notes. Whatever you need to write down, do it. Let's go. Let's say that this angle, we'll call it the red angle, is 60 degrees. Anybody confused right now? Okay. How big is the blue angle? This one, this blue angle, 60 degrees.
Yeah.
Did you guess that right, or did you know that right?
I know that.
Why though?
Because it's the same arc.
Intercepted arc.
Yeah.
Well, how big is the intercepted arc?
120 degrees.
They both describe the same arc. They both start down here and they describe the same arc at the top. So if you multiply it by 2, the orange arc is 120.
Oh, no.
And then if you go back down to the other side, the blue inscribed angle is 60. So realistically, there's 2 angles there. There's 4 angles there.
Whoa.
Because you also have that inscribed angle. Yeah, you do. And you also have its counterpart, that inscribed angle. So they both intercept the same arc at the bottom. visually confusing. You're confusing yourself. I'm not confusing you. So today it's going to be like a puzzle of circles. And I like to nerd out on these. They're so much fun. So here's the last thing I'm going to talk about. Theoretically, I should be able to draw a square that is perfectly inside of this box. I cheated.
Oh.
Boom. Siri's not going to help you. Okay, so how big is each angle in a square? 90 degrees. 90, 90, 90, 90. So, how big is that arc? 180, because 90 times 2 is 180. How big is that arc?
180.
So if you add those two arcs together, how many degrees do you get? Does that make sense that a circle has 360 degrees in it? Pretty cool, huh? I think it was awesome. Alright, so let's get to just some small little bits and pieces. We talked about this. It says if you have a chord AB and you have a chord BC, the intercepted arc is AC. That's the arc they intercept. That's formed by the inscribed angle ABC. That's the first thing at the top of your notes. The next picture looks like this. It says if you have two inscribed angles that intercept the same arc, those two inscribed angles are congruent to each other. Now we've already done all this stuff with my colorful pictures on the first circle. What we haven't got to is kind of this page right here. So we have three corollaries. Right? So in your notes it says if two inscribed angles intercept the same arc, the angles are blank.
The same.
AKA in math we call that those two angles are congruent. Now, corollary number 2 is pretty specific. An angle that is inscribed in a semicircle is always... So let me draw you a picture. It's down here. An angle inscribed in a semicircle is always...
180 degrees.
The semicircle is 180, but the inscribed angle is 90 degrees. It's always a right angle. Right? Angle ZWX is inscribed in a semicircle, or it intercepts a semicircle. That angle will always be 90 degrees. So because this inscribed angle intercepts this semicircle, it's also 90 degrees. Now, anytime you have a quadrilateral, that is a shape that has 4 sides, anytime a quadrilateral is inscribed inside of a circle, opposite angles are always supplementary. Do you understand what that one means? That is by far the quickest trick to use in any sort of math that we're doing, and it is often the one that is the most overlooked. This is 90 degrees, and this is 90 degrees. Right? Do 90 and 90 add up to 180? So if I threw out something random like this was 80 degrees, could you solve for that one? It's 100. Because opposite angles are always supplementary. Alright, that's the one that's the most often overlooked. And the last one, it's just kind of a small variation. Anytime you have a tangent line in a chord that intercept a circle, it says the measure of the angle formed by a tangent in a chord is half the measure of the intercepted arc. Does that kind of make sense? So, 2 trains of thought here. How many degrees are in a line? Yes, in a line. 180. So a linear pair, a line is 180 degrees. So we can kind of walk ourselves through this proof. Let's say 120 degrees right here. So if this angle is 120, how big is its linear pair, its supplementary pair? 60. So if we use the math we just talked about, if I do 120 times 2, that means that this arc is 240. If I do 60 times 2, 120. Do 120 and 240 add up to 360.
Yeah.
Perfect. So it works. So it doesn't just have to be an inscribed angle. It can also be a tangent line and a chord. That's kind of the last case, the special case, and we'll look at that at the very end. So you guys have, I printed off, I made the circles pretty big for you in your notes so you can follow along and scribble it down. So a little bit quicker today because you already have everything drawn for you. You just kind of have to math through it with me. I'm going to try and use colors to make it more obvious. Whatever you have to do on your notes to kind of follow along. So here's the first example in your notes. I'm looking for the measure of angle A. I'm sorry, the measure of arc A.
Oh, 48.
So to go from here to here times 2, 48 degrees. You like it or not like it?
I like it.
Easy peasy. You get one of these. These are good. All right. Same thing here. So because this arc is 88 degrees, its inscribed angle is half of that, or 44. Pretty high level stuff here. If you want to use sine, cosine, and tangent, don't, because that doesn't work. Oh, yes. Feel free to think out loud. Go ahead.
If you add 90 and 96, then subtract from 360 because there's 360 degrees in the circle.
So right now we have an arc measure of 186 degrees. You know, or you should know, that a circle has 360 degrees total. So if you subtract what they already give you, it leaves you with
174.
So that means that this arc is 174 degrees. Now we can cut it in half and find the measure of the inscribed angle. 87 degrees. So just a little bit more complicated. I'm asking you guys to apply a couple more ideas in your head, connecting some concepts to get the right angle measure. Yeah, good day. Easy Friday? Just me?
I'm scared.
Me scared. Here we go. Couple of different things going on in here. Now we have 3 chords in a circle, which has 2 inscribed angles. What's that? Go ahead. Lots of different ways to do this. Lots of different strokes for different folks' techniques here.
Take 56 and divide it by 2.
That would work. So we have this 56 degree arc right here, which means that this angle A is
Oh, it was 28.
28 degrees. Good.
And then angle B is 47 degrees.
We have this 94 degree arc right here, which means that this inscribed angle is 47 degrees. And because that shape inside that circle is a triangle, there has to be 180 degrees in this triangle. So we're looking for that missing value right there. 105? Yep. So that means that this angle is 105, aka this angle is 105. Now we have to figure out how big C is.
Vertical and
Vertical angles. Because they're vertical angles, they are congruent. That means that C is 105 degrees. I know where you're going, and you're absolutely wrong. Go ahead and say it.
But if you multiply that by 2, it's going to be way over 260.
Did I confuse him?
He
He confused himself. Now, Blake, I urge you to revisit what an inscribed angle is. Where does an inscribed, what does it look like? An inscribed angle goes from here to here and back. So and Blake was like, hey, look, here's an angle in a circle. This is 210. Well, and then this one's 210. And then you add them all together and you get like
360.
570. Because I've already done it. It doesn't work. So if you just add those three together, you get 360.
Yeah.
It doesn't make any mathematical sense. That's not an inscribed angle. That's just an angle in a circle. That's Monday's topic.
just angles and circles.
Angles in circles. The intersection of two chords, not where two chords make an angle in a circle. Not bad.
Hey,
Hey, great teaching moment, Blake. I appreciate you.
no problem. Anytime.
Okay. The most often overlooked easy theorem in the book.
Angle A was 82 degrees.
Opposite angles are supplementary.
Top A is 82.
That's cool.
Oh,
Do you multiply 76 by 2 and then subtract?
So that would be a good topic here. I know that this angle right here is 76 degrees. That means that this whole arc is
38.
double it. Inside out we double. Outside in we
yeah.
half. So I know from here to here, from this point to this point is 152 degrees. But I already have 34 degrees that are spoken for. So 152 minus 34, 118 degrees right here.
I'm confused.
Okay?
How'd you get 82?
These two angles are always supplementary because of that most often overlooked theorem that opposite angles of an inscribed quadrilateral are always supplementary. Now we can math around and solve for that. It takes a little longer. It still works, but that's the quickest way to do it.
Oh, you just do the same thing, but from angle A.
So angle A we discovered was 82 degrees. So that means that this arc is
164.
164. Now, from here to here is 164. So you subtract 34 and you get 130. And while we're there, let's just go ahead and figure out the last arc measure. So we have this arc right here is 118. This arc right here is 34. And this arc right here is 130. So what's left over for that missing arc at the top? 78 degrees. So then you can go back and you could justify a lot of different things. Maybe you said this is 76, so you know that this one's 104. And when you add the 78 degree arc and the 130 degree arc, you get 208, and half of 208 is 104. It always works out. It's like a little puzzle around the circle. Is this fun? Fun for me.
We got 80.
40.
So, how How big is this arc right here? Which means that this angle,
It's 90. Oh,
because half of 200 is 100. Alright? Then how many degrees are in triangle?
180.
So how big is angle A?
40.
So I think Josh, you went here, right?
Yeah.
Which is fine because you have 80 and 200 is 280, which means that there's only 80 degrees left for this arc, and you could have mathed back in and back. A lot of different ways to do it. A lot of different ways to do it. It's hard to teach or it's hard to correct because I don't know which path you're taking, but I can just kind of give you the one that I go to first. Let's see where you guys go. 70. I'm assuming you're talking. This arc is 140, so the inscribed angle B would be half of that, or 70.
A equals 60.
A equals what?
60 degrees.
So I'm thinking you did 80 and 70 make 150. That means there's only 30 degrees left over for that angle, the inscribed angle at the bottom. If this inscribed angle is 30 degrees, that means that the arc that it intercepts is 2 times 30, or 60.
And the other arc is 160.
And then the bottom arc. 160.
And 60 plus 140 plus 160 add up to 360 degrees. So even though you nerd out and do extra, it's always a great way to check your math and make sure it works. Yes. Yes.
A equals 90 degrees.
What?
Because it's inscribed in the semicircle.
Because A is inscribing a semicircle. You know it's a semicircle because the chord cutting through the middle of a circle is called the diameter. So that means that A is automatically 90 degrees. Yes.
The missing, on the one with the 2 variables on it, the other one is 37.
This one right here? What are you talking about?
That one, yeah. The
This
here.
one angle? So if you see this arc is 74, that means the angle that inscribes it is half of that, or 37. Which gives you the ability to solve for B. What? What? 53, you're right. Because 37 plus 53 plus 90 equal 180. How big is this angle right here?
Or what if you solve to the arc from 40 to 80?
From 40 to 80.
No, it's like,
Right here?
yeah.
Yeah, that's a lot of work.
That was faster.
What? How big is this angle? 90, because it's inscribed in a semicircle.
And the other one's 50.
Oh, I broke Taylor. Alright, look. Angle, semicircle. How big is that? 90. 40 plus 90, 50. But either way, $180.
The top one's 106.
106. And you check your math here. Does 77 plus 87 equal 180? Because they're opposite angles inside an inscribed quadrilateral.
Yes, I did the math.
Look at all that fun stuff we can do. This one?
All the angles are 60 and then.
How? Whoa. You can't just say, hey, all the angles are 60.
Yeah.
Well, equilateral triangle means that all the side lengths are equal.
Which
Which
means all
which
the
means all
angles
the
are the
angles are
same.
equal.
A is 126.
Which means it's also an equiangular triangle. And because it's equiangular, all the angle measures are 60 degrees. So that makes, if that's 60,
120.
You just have to know, sir.
This is the best thing we've done all year.
Yeah.
It's on Monday.
Oh no.
Even better.
Good for you. Good luck. Monday's so complicated, I split it into 2 days. Yeah, me better.
Why?
All right, so the kind of the last layer here. So no, it's no longer 2 chords. Now it's a chord and a tangent. So if this angle right here is 106, A would be double that size, or 212. So the linear pair for the angle down here would be 74 degrees, because 74 and 106 make 180. If you double 74, you get 148, and you can double check that 148 and 212 add up to 360 degrees. Good stuff here, huh? If this arc measure is 112 degrees, A would be half of that, or 56.
And then we use 121.
Because A and B are a linear pair, they add up to 180 degrees.
And then the arc is
248. And 248 and 112 add up to 360 degrees. That's the last one. 108 divided by 2.
54. 54.
Which makes a
So if you add all 3 of these angles together, they should add up to 180, which makes A 66 degrees. Still looking for C? 60 times 2 is 120. You can double this one as well. And all the way around the outside adds up. Okay, so allow me to connect geometric concepts. Are you ready? Yes? Let me draw you a little picture.
Do we write this down?
Yeah, you do you. You do you, boo-boo.
Okay.
Let's go with a pentagon. That's always a fun one. Oh. That's all you get?
X is.
Oh wait, that's easy. It's just 360 divided by 5.
How dare you ruin my fun? You're right. But how do you know that?
Because the Pentagon has 5 sides.
Equilateral. It's a regular.
Because all the chords are congruent. All the intercepted arcs are congruent. So yes. So this is 72. Which means how big is this one?
72.
Which means how big is this one?
72.
Now, you could also justify that this is an inscribed angle, right? So how big is y?
Oh, like 36.
Look, it describes this
Oh,
arc right here. So 72 times 3 divided by 2 is 108?
Yeah.
Now, still have I pulled anything from not this unit to do this? Inside of a regular polygon,
Wait, we learned this?
the measure of one interior angle is equal to n minus 2 times 180 divided by n. How many sides does that pentagon have?
5.
So 5 minus 2 is 3. 3 times 180 divided by 5 sides.
32.
It's amazing, isn't it? So you can do any kind of math you want to get to either answer you
Why
want.
did we bother learning the other game? If you're good at that.
That was what you guys just learned was quicker than going back to this. You're like, did I learn this?
I didn't.
I don't know. Probably not, but guess what? I taught it.
Oh no, I don't.
I'll reference back to the law of cosines.
I take a fail.
Did you learn that?
Yeah.
I taught it. Let me reference some proofs.
No.
Did you learn it?
I learned
And I taught it. And I will continue to teach it to ruin your day, all day, every day. All right, so while the recording's still going, let's see what you're going to do for homework.
Let's do 1 through 9.
Why homework on Friday?
Because he said he wants to ruin our day.
Oh, today is Friday.
1 through 16.
You ruined
1 through 16 solved.
Some of these are pretty quick. 1 through 16, as you get towards the tail end of it, it gets a little more complicated. 14, 15, and 16 are more of those like super pre-AP problems. 1 through 16 is not terrible. You have all weekend to work on it, and then we'll look at it Monday when you walk in. So Monday when you walk in, we'll be looking at intersecting chords, which create an angle either inside or
Why?
secants. Okay, so we'll cover the last one, secants, and then we'll do Tuesday. We'll look at the numerical length of a secant, tangent, or chord, depending on what's drawn for you. So I'll give you guys the last 15 minutes to kind of work on that and see how much you can demonstrate that you know.